Hello, my name is Rob Reynolds. Welcome to Mat-073. Today we're in Chapter 5, and we're going to be looking at your favorite topic, word problems, specifically some work problems, and then some proportion problems, and then motion problems. So 3 different types of problems. They're worked a little bit differently, each one, but all 3 of them require some reading, which is not usually what math students enjoy. So we'll see if we can break this down. Matt and Adam need to repaint their parents' house. Matt can do the job alone in 45 hours and Adam can do the job alone in 60 hours. How long will it take the 2 of them to work together to paint the house? So you might think, well, the easiest approach would be, oh, let's just take the 45 plus the 60 and divide by 2. But this answer doesn't make sense because that means that it takes 52.5 hours to paint the job together, but if you remember, Matt could do it by himself in 45 hours, so it should be less. So this is not the approach that we want to take. Instead, assuming that Adam is being helpful and he's not hurting Matt's chances of getting the job done, this doesn't make any sense. So let's talk about the Matt's rate of work per hour. So if it takes him 45 hours to complete the job, after 1 hour, he has 1/45 of the job done. And so we'll multiply that by t because we don't know how long he needs to be working at that rate. But this is his rate of work. And so t is how long he needs to be working at that rate. And so then Matt, so we're going to add Matt's rate of work, and he's going to be doing 1/60th. He'll complete 1/60th of the job, and we don't know how long he needs to be working that job, but we do know that after so much time they will have 100% of the job done, or they will have completed the entire fraction of the work. So if you watched a previous video on how to solve these equations, I would multiply through by a common denominator. In this case, 180 looks like the least common multiple. We'll start multiplying. 4t plus, let's see, 180 divided by 60 is 3 equals 180, so 7t equals 180, and we finally get the time that it's going to take them both, because it's the same. It doesn't come out nicely, but 25.7 or more specific, I'd probably just leave it 187th hours, because usually in math we like exact answers, and it doesn't say to round anything, so I would probably just leave the answer. Let's see how the author went through. They said familiarize yourself with the problem, and well, you're welcome to read through this. Maybe this makes more sense than what I explained. So they're kind of talking about Matt would paint half the house in, half the time. So they're trying to figure out his rate of work per hour. Oh, good. That's what they did. Per hour, Matt's rate of work is 1/45. Adam's rate of work is 1/60th. And so this is their sum. For how many hours. So they're explaining how I just jumped to the 4. Oh, good. They did the exact same thing. So here it is. The rate of work times time, 1/60th times time, and then they went ahead and solved. Boy, that's a lot. Whoa, they got the same answer that I did. Good. 187. Perfect. And then you go back and check the thing and make sure that that's the, see, there's that 4 sevenths and 3 cents for the whole house gets completed. All right, so, oh, good. The general formula, I would have written this, whenever it's a work problem, I would always do all work problems the same. I would say his rate of work times time plus the other person's rate of work times time equals the whole job getting done. But remember, if you multiply this together, this is really t over a. And t over b equals 1. So that's the general form. Another type of problem that you'll run across is distance equals rate times time problems. So instead of work, we have a nice formula. If they start talking about how fast something goes, that's the speed or the rate, miles per hour or something. And there's the distance. So oftentimes what's helpful is a nice chart to organize our thoughts. So we've got two people here. We've got Jake and Josh. And I'm just going to write the formula up here. Distance equals rate times time. And let's just fill in. As we read, we'll just complete the chart. So let's see. Jake's scooter goes 4 miles an hour faster than Josh. Well, that's a rate. Unfortunately, we don't know what Josh's rate is, but we do know that Jake is 4 miles an hour faster. So if Josh is going 10, Jake must be going 14. So since I don't know what Josh is, we'll just let Josh's rate be R. So that's the first part of the sentence. Next thing it says, in the same time that it takes, now this, I added the word same, but I wanted you to see that however long it takes Jake, we'll call that time 1, Josh takes the same amount of time. So we know from this that time 1 should equal time 2. Jake's time should equal Josh's time. So let's see. Jake is going to travel now 54 miles. So we'll put that here. And Josh travels 48. And I think I have everything I need. By the way, if distance equals rate times time, then if I divide through by R, I get a nice little formula. Time is distance divided by rate. So that's what I'm going to do. I'm going to take this distance for time 1, take the distance and divide by the rate, and set that equal to Josh's distance divided by Josh's rate. And then again, if you don't know how to solve this, I would recommend that you watch a previous video where I talked about how to cross multiply. The yellow diagonal should equal the pink diagonal. I don't know if you need for me to complete this. The hard part is setting these things up, so I think it'd be more beneficial for these videos for you just to see how to set these up, because I think most of you can solve this. What's that, 192? So if I subtract off 48, 6, see, I don't want to spend time number crunching. So R is 32. But by the way, make sure you answer the question, because it says find the speed of each. So if Josh, we just found, is 32 miles per hour, then remember Jake is 4 miles an hour faster. So 32 plus 4 is 36 miles per hour. All right, so good. They did a chart too. Familiar? Oh, they did it interesting. They said Josh is 4 miles slower. So remember, I had an R plus 4 here, and then I just had R. So they did it back. Well, that's nice that it's worked out differently. Don't be worried that you're going to work it out wrong. I think we should get the same answer, because when we cross multiply here, I think we'll end up fine. They just approached it good. They got R equals 36, but remember, their R in their chart was Jake's time. So that was the same answer that we got. Jake was 36, but remember, our R was Josh, but their R was 36, so then they would have done R minus 4 to get to the 32. So either way, I think you'll be good. So here's checking the answer, and then again, final solution. Jake's speed is 36, and Josh's speed is 32. Let's try that again. I can see that they're talking about oh, this is a little bit different. This doesn't say distance equals rate times time. This kind of talks about calories, how long. You know, I wonder if this is just extra information, because it's saying how many calories will you burn in this amount of time. So all I need is calories is to time. I'll set up a proportion as calories is to time. So I think sometimes they throw extra information and that freaks students out that they're not using the 170, but I don't think I need it. So let's see. There's 345 calories. I'll put a C there for calories for every 45 minutes. And then it says how many calories. So I'll put X calories. That's confusing, but I don't want you to think that that's a C. How many calories, we'll let that be X, to burn. Now wait a minute, this is 2 hours and this is in terms of minutes. That's annoying because we need calories as to minutes as calories as to minutes. So we have to make sure our units are the same. So I'm going to take the 2 hours and multiply by 60 minutes in an hour and end up with 120 minutes. So that way when I cross multiply, oh Lord, that's a big number. And divide through by 45, I'll get 920 is X. Let's see how they worked it. Yep. They defined it a little bit differently, but the number of calories. Oh, they did minutes as to calorie and minutes. So again, I don't want you to worry. I did calories as to minutes as calories as to minutes. It's nice for you to see that there are other ways to work this problem, but the important thing is that we're just setting up ratios. I wonder if they talked about that extra. They didn't really talk about that 170 being extra information. But they didn't use it either. Okay, bicycling. Okay, so this is a speed, this is time, and oh, this is a distance. So I think I'm going to go back to distance equals rate times time. But remember, we can always solve for time and say time is equal to distance divided by rate. If I just divide through by rate. Shouldn't have done red. It was a terrible color. So remember, time is now distance divided by rate. So whenever they say find the speed, no, I'm not going to. I take that back. It's not a whenever. Each problem is a little bit different. Let's read it before I... Oh, here's the problem right here. Okay, so we'll go. So let's set this up. A racer, I want a chart. I do these best by organizing my thoughts. I'm not going to read all this. That is annoying for me to even look at. So let's see. We have a racer bike and we have a mountain bike. So I'm going to say racer bike and mountain bike. And I'm going to say distance equals rate times time. And I'm going to keep reading. The racer bike is 15 kilometers per hour faster than the mountain bike. Well, they didn't tell me the mountain bike's rate, so I'll let that be R. The mountain bike is R. And then so the racing bike is R plus 15, because it's the racer bike has thinner wheels and it's just going to go around. So it's, oh, and they give me the time that it takes the racer to travel. Okay, in the same time that it takes the racer. So boom, this is time 1 and time 2. And again, I know that I'm going to be setting time 1 equal to time 2 because it's the same time. So this is similar to the previous problem. The person on the mountain bike has gone 50 kilometers. Mountain bike goes 50, and this 80 kilometers must be the racer. Yep. All right. You can read through that if you'd like, but I'm not going to because I think I have everything I need. Time is distance divided by the rate, R plus 15, and I'll set it to the mountain bike's distance divided by the rate. And then again, I think you're home free from here. If you need help working out this kind of problem, then you need to go back and kind of re-watch previous videos. But I would set the pink diagonal equal to the blue diagonal. Let's see if they did that perfect. They did it right here. Fantastic. So here's how they worked it out. You'll eventually get down to this statement. Yeah, I guess this is the statement for that I would be looking for. All right, so I'll move on. But I think we could eventually get down to an answer. But remember, answer the question. If R is 25, then we probably need the speed of both. And so it looks like we're going to answer the question by sharing the speed of both. The mountain bike is 25, and that means that the racer is 40. Okay, the last example is talking about a barge going downstream and upstream. So I think I'm going to, instead of a mountain bike and a racer bike, the two different things is down stream and upstream. But I still think distance equals rate times time. So I'll start with this again. And let's talk about this 98, because it's the first number I see, and it's the river. The 98 is the miles, so it's a distance down. So that's 98, a distance down. Oh, and it looks like it's a 52 up. So I'll put 52 here. The speed of the current. Now, the current, this is interesting. This is a little bit different. So they say find the speed. So we're going to find R. Now, do you agree that a boat going down the river is going to be increased by the speed of 2.3 because it's going, so going down is always faster than going up, because going down is with the stream, and then going up is against. So maybe I should have named these with the stream and against the stream. But the important thing is your barge has a motor on it, and it's propelling it at a certain speed, but the current is actually increasing the speed of the boat going down, but then you're fighting against you on the way up. So it's decreasing. So your barge might be going 20 miles an hour, but because the current is pushing against you, going against the stream or going up, you're not going to be really going 20 miles an hour. You go 20 minus the current speed. So, let's see. Does it say that it's the same time? Yep, same time. So again, t sub 1 and t sub 2 should equal. So let's do it. T sub 1 equals t sub 2. T sub 1 is distance divided by rate, and that should equal distance divided by rate. So this is a little bit harder to cross multiply and divide because you have a little bit more numbers to worry about, but it's the same concept. I think you'll be okay. The yellow diagonal should equal the blue diagonal, and I'll see if they worked perfect. That's what they have too. So 98, good. And then here's where they cross multiply. And remember to answer the question, which was what? Find this S is the speed of the boat. You're done, because the speed of the boat is 7, or the barge is 7.5 for both. It's just altogether the speed going downstream is faster than the speed going upstream. All right. I hope you found this video helpful. This is a difficult lesson. If you have questions, feel free to shoot me some emails in the homework by hitting Ask Your Instructor. Good luck.